Hey guys, today we're going to focus on converting from rectangular units to polar units and from polar points or polar units to rectangular units. We're going to go both ways, okay? So that's what we're doing today. That's the focus. The thing you have to walk out with today is being able to change from polar to rectangular and rectangular to polar. Alright, well, let's dive right in. So the first thing we're going to do is we're going to change rectangular points to polar points. This means you're going to take an x and a y, a Cartesian point, x comma y, and change it to being an r comma theta. Okay? So let's take a step back real fast and let's think about what it means to be a Cartesian point, an x comma theta. An x comma y. Okay? Well, we see here that I've plotted the point 12 comma 5. Okay? And we know that 12 is the horizontal distance. Okay, that's what a Cartesian point, that's what x stands for. Okay, it is how far it takes me horizontally to get where I want to go. So in this case, it took 12. Okay, and 5 is the vertical distance it took me. So I went horizontally 12, and then I went vertically 5. So it's the point 12 comma 5. That is what a Cartesian point is. Let's think about what a polar point is real fast. A polar coordinate, we mark a point by how far away it is and what angle it is. So that's why we call r, you heard me in class say it was a directed distance, because we just mark by how far away it is. So for this example, our r is 13 and our theta is 22.6. Now a quick side caveat. Our homework is going to be not in degrees and radians, but in this problem we're dealing with degrees, okay? But most of your homework will be in radians. I will do an example for a radian problem at the end, okay? So we have a directed distance of 13 and a theta of 22.6, so r comma theta would be 13 comma 22.6. Alright, so let's dive in. I want to convert. Well, look, I have this triangle. Take a step back for a second. I went right up, okay, so it looks like I have part of a triangle, and then if I add in the r theta, I have the hypotenuse and I have the angle. So I have this beautiful triangle, where for this example problem, r is my hypotenuse, x and y are the legs, and theta is the angle. Okay, so to put it in the scope of these exact numbers, if you used x and y as 12 and 5, could I now find r and theta? Yes, you don't even need any more instruction from me. You should be able to look at them and say, oh yeah, r is the hypotenuse. I can find the hypotenuse by simply saying r squared, okay, because that's the hypotenuse, right? R squared, because that's the hypotenuse. I'm trying to find the square. It's in other. R squared is equal to x squared plus y squared, which in this case would be 12 squared plus 5 squared. Okay, and then you could do the rest of this without me, but just because I'm here, I'll follow through on it. R squared is going to be equal to, well, I know that 12 squared is 144. I know that 5 squared is 25. I add those two together, I get 169. You square root both sides, and you get r equals 13. Now, it technically could be a positive 13 or a negative 13. But since I know I went out to the right on my x, I want it to be a positive 13. But if I had gone out to the left on my x, I'd want it to be a negative 13. Because we've talked about how r can either be a positive directed distance or r can be a negative directed distance. Okay? Let's do another problem here. Well, not another problem, but let's find theta. I apologize for misspeaking there. Let's find theta. Now think to yourself for a second. How can I find theta? Well, I know the opposite from theta, and I know the adjacent from theta. Is there a trig ratio that deals with opposite and adjacent? SOHCAHTOA. Because this is a right triangle, right? This is a right triangle. So, is there a trig ratio that deals with opposite and adjacent? There is. Tangent. SOHCAHTOA. Tangent. So I know that tangent theta is equal to 12 divided by 5. Because that's, I said that backwards, my apologies. 5 divided by 12. That's opposite divided by adjacent. Now, I don't want theta, I don't want tangent theta, I want just theta. So I can take the tangent inverse of both sides. So you would just say, so then I could say that theta is equal to tangent raised to the negative 1. Sorry, there's no little negative 1 in typing. Tangent raised to negative 1 of 5 divided by 12. Now you might be wondering, how do I get that number? Well, that's where a calculator comes into play. You can say theta is then equal to, you got a calculator, turn it on, come on, turn on, and you hit second tangent, and you just say 5 divided by 12. Close the parentheses, press enter, and you get 22.62. I'm just going to say 22.6 for now. And we're going to put that in degrees. Again, most of your homework will be in radians, but for this sake of this beginning example problem, it is in degrees. So we have the polar point 13 comma 22.6. So we know the polar point is the point 13 comma 22.6. And none of this was really new information. This was all old information. Just understanding that it could be put as a triangle and then seeing that this is a right triangle, so it's very simple to do from there. Okay, it's just remembering what we did at the beginning of the year, SOHCAHTOA. Alright, and remember how to find, the hypotenuse of a triangle given the two legs. A squared plus B squared is equal to C squared, where C is the hypotenuse. Alright, but let's say none of that makes sense to you. Let's break it down then. You can simply find the r comma theta, so if you want to go from x comma y to r comma theta, it is simply r is equal to the square root of x squared plus y squared. And theta is simply equal to tangent inverse of y divided by x. Alright, now my handwriting is terrible, so I copied this from a website. Alright, but you can see that r is simply equal to the square root of x squared plus y squared, and theta is equal to tangent inverse of y divided by x. Again, you can just think of it as the triangle, okay, but if you don't want to, you just kind of want to have a couple formulas to memorize and work with, right here. This is your sweet spot. To change from rectangular to polar, this is how you do it. Alright, let's do another example. Let's go the other way this time. What if I wanted to go from the polar coordinate 13 comma 22.6 and I wanted to change it to a Cartesian coordinate, which would be an x and a y? Well, a polar coordinate is the hypotenuse 13 and the angle is the angle of the right triangle 22.6. So now you should just ask yourself, okay, based on what we just thought about, is there a way that I could put all this stuff together? Is there a way that I could isolate x? Is there a way I could deal with x? Well, you know the angle, right? You know this is a right triangle, so we know our trig ratios work, sine, cosine, tangent. So angle, adjacent, hypotenuse, SOHCAHTOA. Oh, that's right. Cosine would work with this. I could say cosine, which is cosine of an angle, is equal to adjacent divided by hypotenuse, so x divided by 13. And then you just solve for x by multiplying both sides by 13. And then I can just grab my handy dandy calculator and type that in. 13 cosine of 22.6, close my parentheses, press enter, and I get 12 point some. We're going to round that to 12 for now. So then we see that 12x is approximately 12. So now, is there a way I could apply that same kind of logic and get the y value of the point? Well, let's see here. Y, it's opposite the angle. I know the hypotenuse, SOHCAHTOA. Sine of 22.6 is equal to y divided by 13. Now you multiply both sides by 13, so 13 times sine of 22.6 will allow me to isolate for y, and then I just do the same thing. I grab my calculator and I simply type it in. 13 sine 22.6, I close the parentheses, I press enter, and I get 4.9958. I'm going to round that to 5, so that 5 is equal to y. So I know that the polar point 13 comma 22.6, where r is 13 and theta is 22.6, is the same as the Cartesian point xy as 12 comma 5. And I just used all this stuff I've known before. It was no new information. But let's say you don't want to think about old information and you want to just get some formulas to memorize. Here you go. X equals r cosine theta, y equals r sine theta. So if you have a polar point, r theta, and you're trying to convert it to a Cartesian point, xy, you can simply say x equals r times cosine theta, y equals r times sine theta. Alright? Now, for this example, for these last two examples, I did everything with degrees. But your homework is not in degrees. Your homework's in radians. So let's look at a problem together that deals with your homework. Here's a quick slide for just saying what we've already said. It's just in neater, nicer ways in my handwriting. Okay, rectangular to polar, r equals square root of x squared plus y squared. Theta is equal to tangent inverse of y divided by x. That's rectangular to polar. Polar to rectangular is x equals r times cosine theta, y equals r times sine theta. Okay, let's do an example. Let's change so now we're going to deal with an example that deals with radians. Let's change the polar point 4 comma negative pi over 3 radians to a rectangular point. So we have an r and a theta, and we want to change it to an x and a y. Well, to get x, it's r times cosine theta. So you'll just simply say x is equal to r times cosine of theta. And then for this problem, we know that information. We know that r is 4, and we know that theta is negative pi over 3. But I do not want you guys to give me an approximate calculator value on this. I want you to think about, can I get this information off the unit circle? And the answer is yes. I know it's a negative angle, so you need to think about where would negative pi over 3 fall. Well, I happen to have my handy dandy chart here. Okay, I know it's really hard to see, and if you can't really see it, that's okay. But I know that positive is counterclockwise, negative is clockwise. So I know that I am 3 lines up on this chart. It might look a little bit different depending on the chart you have. But I'm 3 lines up on this chart and going in the positive direction to get to pi over 3. So if I negative pi over 3, I just go 3 lines down. And I see that I would fall at 5 pi over 3. So cosine of 5 pi over 3 is just 1/2. So now I can just simply say x equals 4 times 1/2. And I know 4 times 1/2 is just 2. Awesome, I had the x. To get the y, I just simply say r times sine of theta. And then I know what that information is for this problem. I know that it is 4 times sine of negative pi divided by 3. I'm kind of running out of time, so I'm going to start typing a little bit faster. So then y is equal to, now, I already know that negative pi over 3 is the same thing as 5 pi over 3. So I can say 4 times, so I look at sine of 5 pi over 3, and it is the y value, and that's negative square root of 3 divided by 2. So I don't have a square root symbol, so I'm going to draw this. I apologize. Negative square roots of 3 divided by 2. All right? And now, hopefully you've been paying attention all year, and you know that when you multiply a whole number into this, it's going to multiply to the numerator, but it does still reduce with this denominator. So I'd get negative 2 square roots of 3. So then I know that if I'm changing this polar point to a rectangular point, the polar point 4 comma negative pi over 3 is the same thing as the rectangular point 2 comma negative 2 square roots of 3. Okay? Now let's do another example. Let's change a rectangular point, negative 7 comma 0, to a polar point. And I think you'll be a little shocked at this answer. All right, but let's change this rectangular point to a polar point. So first, let's jump back a couple slides. We know to change to polar from rectangular, r is equal to the square root of x squared plus y squared. So we know that r is equal to the square root of negative 7 squared plus 0 squared. I'm running out of time, so I'm going to jump ahead here, but we know that r should simply be equal to, well, you calculate all that, and you're going to get the square root of 49. Okay? Now, we know that when you're taking a square root, you can have either a positive version or a negative version, because you got to remember the square started over here at the r, so you had to square root both sides. So there's a positive version and a negative version. For this problem, which one's the correct one? Well, think about it. This point, is it on the left side or the right side of the axis? It's on the left side. So I want r to be a negative 7. All right, so now I got to find theta. Theta is equal to tangent being raised to the negative 1. I'm running out of time real fast here. Tangent negative 1 of y over x. So you can type this part into a calculator, and I've already done that, so I'm going to jump to it. But tangent inverse of 0 divided by negative 7, you grab a calculator, type that in, you're going to get 0. So it is the same point. That's the surprising part. It's the same point because of where it falls on the axis. Okay? It is the exact same point. Not everyone will do that. In fact, several of them will not. But I just wanted to show you this one so you're not shocked about it. Okay? Please let me know if you have any questions. In all honesty, tell me ways I could improve this video. All right? Thank you. Have a great day.